Hi students, in the previous class we discussed about a simple RL series circuit, RC series circuit and RLC series circuit, right? So and we came to know that in case of any circuit where the inductive reactance is a dominating component, in that case the current will be always lacking. Similarly, in case of the capacitive reactance dominating component, then the current will be always leading by an angle of phi. Today we will solve some problems on RC and RLC circuit, right? So let us take down the problem. A circuit consists of a resistance of 25 ohms and capacitance of 100 microfarad connected in series. A supply of 200 volts at 50 hertz is applied across the circuit. Find the current, power factor and power consumed by the circuit. At last we need to draw the vector diagram, right? So see the problem here. What they have given? They have given there is a resistance of 25 ohm and there is a capacitance of 100 microfarad is connected across 200 volt power supply. Hence, let us draw a RC series circuit across a 200 volt 50 hertz power supply, right? So here you can easily see the circuit. RC connected in series across 200 volt. Now, in order to solve this problem, first we require capacitive reactance, and we know the formula for capacitive reactance, that is Xc is equals to 1 divided by 2 pi Fc, or Xc is equals to 1 divided by omega c. Xc is equals to 1 divided by omega c. 1 divided by 2 pi f c, ref is 50 hertz, therefore we will get Xc is equals to 31.85 ohms, right? So once we get the value of Xc and we know the value of R, we know that Z is equals to under root of R square plus Xc square using Pythagoras theorem. Substitute the value of R, Xc, then we will get impedance as 40.48 ohms. 25 square plus 31.85 square, and total this value will be under root, hence we will get 40.48. Once we know the total impedance and we know the total voltage applied, then we can calculate the current as I is equals to E by Z, that is 200 divided by 40.48, we will get I is equals to 4.94 amperes, right? So as it is a capacitive circuit, that is RC circuit, here the current will be, yes, here the current will be leading with respect to voltage, that is, now we will calculate the power factor. Cos phi is equals to R by Z. We know the value of R 25 ohms and we know the value of Z, it is 40.48. If we substitute 25 and 40.48, we will get 0.617, and as it is a RC circuit, the current will be leading, right? So next we know power is equals to EI cos phi. We know the value of E 200, I 4.94 and cos phi 0.617, then we will get the value of power as 609.59 watts, right? So now in order to draw the vector diagram, because at last what they asked, you need to draw the vector diagram, right? So in order to draw the vector diagram, what we need to do, we need to calculate the value of ER, EC. Therefore phi is equals to tan inverse of XC by R, right? So that is opposite by opposite by adjacent side. Tan inverse of 31.85 divided by 25 will get 51.87, right? So if you want to cross verify your answer, this is your phi, right? So calculate cos phi, that is cos phi is equals to, or cos 51.87, you should get it as 0.617, then only your answer is correct, right? So we know the value of ER, we know the value of EC, and we know the phi. Then we can draw the vector diagram as, take some standard scale based upon ER and EC. As it is 123 and 157, you can take 1 cm is equals to 25 volts or 10 volts, right? So if you take it as 1 centimeter is equals to 25 volts, then 123.5 will be approximately 5 centimeter, right? So it will be 6 centimeter. This is 5 centimeter and this is 6 centimeter. Now draw the origin of first vector and termination of second vector, right? So you should get it as 200 volts and angle should be 52. Then only your answer is correct, right?